11.1a is about systems of equations. So if you think way back to semester 1, we actually talked about linear system of equations before. So now we're going to combine linear equations with quadratic equations. So let's review. This year we've learned about a couple of different functions. So a linear function has a degree of 1. So if you have like y equals 3x plus 6, that's a linear function, and it's a straight line. So that's what our graph would look like. We've been talking a lot about quadratics, right? So that's like x squared plus 6x plus 4. Since it's got that degree of 2, that makes it a quadratic, and it would look like a parabola. So systems of equations, there are two or more equations, right? Two or more equations. So for example, if we had a parabola on our graph and we had a line on our graph, that would be our system of equations. Now try and think back to where our solutions are. So our solution for this system of equations is where our parabola and our line intersect. So solutions are where your graphs intersect. Where the graphs intersect. So that's really what we're looking for. And we write our solution points as ordered pairs, so as x and y ordered pairs. So let's look at a couple of examples. Before we get to that, there are a couple different types of solutions. So we actually have 3 different types of solutions to a system of linear and quadratic equations. You could have no solution, so you could have your parabola and you could have your line and they could not intersect at all, right? So this is no solutions. You could have one solution where you have your line and you have your parabola and they intersect at exactly 1 point, or you could have 2 solutions where you have your parabola and you have your line and it intersects at 2 points. So those are our 3 options. No solutions, 1 solution, 2 solutions. And it's just based on that number of intersection points. So let's take that and apply it to a couple examples. So we want to solve this system by graphing. So we're going to graph this quadratic and we're going to graph this linear equation. So let's actually start with this linear equation. Y equals 3x minus 6. Well, recall that our negative 6, that's actually our y-intercept. So we know our y-intercept is 0, negative 6. And our slope is 3, so we can write that as 3 over 1. So I'm going to graph the point 0, negative 6. So here's my 0, negative 6. And since my slope is 3 over 1, that is my rise over my run. So I'm going to go up 3, up 1, 2, 3, and over 1 to make a point. Up 1, 2, 3, and over 1. And I'm going to keep going just to get this filled in. And then I'm going to connect all of my points. So when I connect all of my points, here is my linear equation. Right there, that's our line. All right, so now we need to draw our quadratic equation. So y equals x squared plus 2x minus 8 is our quadratic. Notice that it is in standard form, so we're going to need to graph it in standard form. So remember, if we want to graph in standard form, we have to start off by finding our axis of symmetry. So we're going to find x equals negative b divided by 2a. Well, our b is 2, our a is 1, so we have negative 2 divided by 2 over 1. Divided by 2 times 1. Well, negative 2 divided by positive 2 is negative 1. So I'm going to draw this down here so we know the x value of our vertex is negative 1. And then we're going to plug that in to find y. Negative 1 squared plus 2 times negative 1 minus 8. Negative 1 squared is just 1. Minus 2 minus 8. Well, that equals a negative 9. So we have a vertex of negative 1, negative 9. So here's my axis of symmetry on negative 1. Here is my negative 9. Okay, and that's our vertex. Well, since we have the a value of 1, right, the a value of 1, if we think about our x, y, a, y table, well, we just need to go over 1 and up 1 and over 2 and up 4. So let's go ahead and graph those points. Over 2, up 1, 2, 3, 4. Mirror that on the other side. Okay, so far I only have 1 intersection point, so I'm actually going to go 1 step farther in this table. Right, if I had the x value 3, well, 3 squared is 9, so I'm going to go over 3 and up 9, and look at that. That is my second intersection point. I'm going to connect these dots. Connect these dots to draw my parabola. So we have our parabola with our two intersection points. Okay, and remember, since the ordered pairs are our solutions, you have to be very, very precise when you are doing this. So we have one solution right here at the point 2, 0, and we have one solution way down here at our vertex of -1, -9. So 2, 0, and -1, -9 are our solutions. Okay, so long story short, to solve a system of equations, you just graph them and you find their intersection points. Let's look at one more together. So we have, again, a quadratic and a linear equation. Okay, so looking at our linear equation again, we've got y equals 2x minus 8. So I'm going to graph our y-intercept of -8. And then we've got our slope of 2 over 1. So here is my 0, 8, and then my rise over run is up 2 over 1, up 2 over 1. Okay, and since I want to be really precise, I'm going to graph in or draw in a whole bunch of these points just so I can make my line very, very accurate. Okay, accuracy is key when you are graphing these things. All right, then we have to connect our dots. All right. Be a little more accurate than I'm being right now, but then we want to graph our parabola. Well, since it's still in our standard form, we're going to do the same thing again. This would be a good time to pause the video and see if you can figure out the vertex for y equals x squared minus 2x minus 4. Well, -b divided by 2a. A negative 2 is positive 2. Divided by 2 over 1 is just 2. And I'm going to draw it down here so I have more room. When I plug my 1 in, I'll have 1 squared is 1, minus 2 minus 4. Well, that would equal -5. So we have the vertex of 1, -5. So here's my axis of symmetry on 1. Here's my 1, 1, 2, 3, 4, -5. All right, and since our a value is 1, again, we're going to use that same table, right, of when we go over 1, we'll go up 1. When we go over 2, we will go up 4. So over 1, up 1, look at that. That's one of our intersection points. Remember, we have 3 different options. We could have 2 intersection points, 1 intersection point, or no intersection points. So looking at this graph, how many intersection points did we come up with? That is right. We only have 1 intersection point for this parabola. So our one and only solution for this problem is the point 2, -4. So that would be our solution. And this is quadratic systems of equations.